Alright guys, welcome to this page of the notes, and here's what we're doing. We just discussed two more characteristics of rational functions. Slanted asymptotes, which you can find by doing long or synthetic division. We'll take a look at that when we do some example problems. And then we talked about point discontinuity, which will be a hole in the graph, all right? And when that shows up, and we're going to go ahead and practice finding that point discontinuity in a couple of example problems before we jump into graphing a couple of functions. So let's go ahead and start with this first one. First thing I need to do is I need to factor the function. So f of x is equal to, all right, let's factor this guy, x squared minus 1. That is a difference of squares. X squared is a perfect square, 1 is a perfect square, so it'll factor into an x plus 1 and an x minus 1. In the bottom, well, it's a general trinomial. Hopefully, it'll just factor into two binomials fairly easily. I don't know, let's find out. I'll spot you the x and the x. The trickier bit, two numbers, multiply to a positive 5, sum to a negative 6. Well, actually, that's not too bad. A minus 5 and a negative 1 will do it. Now, at this point, right, based on what we just talked about, you should immediately recognize, hey, look, I have the same factor in the top as I do in the bottom. But we'll get to that in just a second. Now, remember, to find x-intercepts, you set the numerator equal to 0. Numerator equal to 0. So that means the 0 product property, x plus 1, the quantity x plus 1, times x minus 1 equals 0. 0 product property will split those up. So I will have x plus 1 equals 0 and x minus 1 equals 0. So let's do that right here. X plus 1 is equal to 0, which means x is equal to a negative 1. And x minus 1 is equal to 0, which means x is equal to a positive 1. So at this point, it appears that I have two x-intercepts, minus 1 and positive 1. Let's keep going. Right? We just talked about the fact that when the denominator is 0, you get vertical asymptotes. So we set the denominator equal to 0, but the 0 product property would split those guys up, and we set them both equal to 0. X minus 5 equals 0, which means x is equal to 5, and x minus 1 equal to 0, which means x is equal to 1. All right, now, here's the way this works, guys. What happens is I found, I think, two x-intercepts. But then I go to find my vertical asymptotes, and I get, I think, two vertical asymptotes. But what I notice is that the same value shows up in both the x-intercept and the vertical asymptote column. X equals 1, x equals 1. Guys, when we do these graphing problems, that is your dead giveaway. It is not an x-intercept. It is not a vertical asymptote. If it shows up in both places, it is actually point discontinuity. So what that means is that x minus 1 equals 0, x equals 1 is actually point discontinuity because it showed up in both of these guys, and I actually only have one x-intercept, x equals negative 1, and I only have one vertical asymptote at x equals 5. Any value that shows up both as an x-intercept and as a vertical asymptote is actually neither an x-intercept or a vertical asymptote. It is in fact point discontinuity. Why? Because look, x minus 1 is in the top and x minus 1 is in the bottom. If I plug in a positive 1, I get 0 over 0, which means the function does not exist. And on a graph, that's going to be a hole. Let's keep going. Got another one for you right here. Let's factor this guy, see how it works. F of x is equal to, all right, hopefully this is a general trinomial that'll just factor nice and easy into two binomials. I don't know, let's see. I'll spot you the easy bit, x and x. The trickier bit, two numbers that multiply to a positive 8, sum to a positive 6. Actually, that's not that bad. How about a plus 2 and a plus 4? In the bottom, Well, you should recognize this. We've seen it over and over and over again in this chapter. Yep, that's a difference of squares. X squared is perfect squared, 16 is a perfect squared. So that'll factor into an x minus 4 and an x plus 4. Once again, at this point, kind of cat's out of the bag. There it is, x plus 4, x plus 4. But you won't know that when you're doing these problems, actually graphing these functions. So how will you know that I have point discontinuity? Here's how you'll know. I set the numerator equal to 0. So, zero product property lets me split them up. Ooh, and it looks like I have two x-intercepts, -2 and -4. Great! We move on to the vertical asymptote, set the denominator equal to 0. X minus 4 equals 0, which means x is equal to a positive 4, and x plus 4 equals 0, which means x is equal to, hold up, I thought I had two x-intercepts, and I thought I had two vertical asymptotes, but the same value shows up in both. That is your immediate red flag. It's actually neither. That one is in fact a point discontinuity. And so when we do example problems here in just a moment, whenever that value shows up as both, it turns out to be neither an x-intercept or a vertical asymptote. It'll be point discontinuity. And so I have a hole in the graph at x equals -4. I'll have an x-intercept at -2 and a vertical asymptote at 4. Those ones are still what they appear to be. This one is not because it showed up in both. One more time, just to make sure that you guys have got this down. Let me slide this up just a smidge, and here we go. What a great unit of measure, a smidge. I wonder how much that actually is. Okay, it's a difference of squares, so +2 -2. In the bottom, with any luck, factor quickly. I'll spot you the easy bit, x and x. The slightly trickier bit, two numbers that multiply 6, sum to 5, that's actually not that difficult. A +2 and a +2 and a +3 will get it done. And again, we've done a couple of these. You now recognize, hey, same factor top and bottom. We know that that's going to be point discontinuity. But again, when you're doing these problems and you're graphing them, you won't, right? You're not going to see that. So how will you know? Well, here's how you'll know. You're going to find x-intercepts anyway. X plus 2 is equal to 0, which means x is equal to -2. And x minus 2 is equal to 0, which means x is equal to 2. It'll look like you've got two x-intercepts. But then you'll go on to find vertical asymptotes. So x plus 2 is equal to 0, which means x is equal to -2. And x plus 3 is equal to 0, so x is equal to -3. And now that you've found both x-intercepts and vertical asymptotes, and you go and you look at it and you go, the same value shows up twice. Now that means it's PD. So it turns out that it's a -2. That -2 is neither an x-intercept or a vertical asymptote. It's actually going to be a hole in the graph. And then I just have one x-intercept, +2, and one vertical asymptote at -3. All right, guys, that's the way these are going to work. We're going to do some rational functions, graph rational functions on the next page of the notes. We'll start by finding x-intercepts, vertical asymptotes, horizontal asymptotes. And if the same value shows up in the x-intercept and the vertical asymptote, you will know right away it's PD. All right? Head on over to the next page of notes. I cannot wait to look at these graphing problems with you. I'll meet you guys there.